Hello everyone, welcome to Math Tired Club, where we make all those things that are hard in math very, very, very easy. I hope you're doing well. Don't forget to like, subscribe, and comment, and also turn on notifications so that whenever I upload a video, you will get notified. Thank you for supporting me. Thank you so much. Really, really, really grateful for that. You give me a lot of enthusiasm to make new videos and to be better every day. Thank you so much for your support. Also, check out the shorts. I have uploaded some new nice shorts, funny. Check them out. They're so funny and they will actually make you laugh. They make me laugh, so I hope that they would make you laugh. So yeah, today in this video, I had a video earlier on translation and transformation, which I'm going to link in the description box below, which I explained completely how translation and transformations are. Then I'm going to, like in this video, I'm going to add another example. I'm going to talk about absolute value functions. So I hope that you will understand and learn this one too. Don't forget to watch the previous video, because in the previous video, I completely explained how translation and transformation are formed. And in this video, I'm going to have another example of another type of graph. So it says graph the function below using translation and transformation. Now I have an absolute value function. As I said, the very first thing that you need to start with is the parent function. And the parent function is the simplest form of that function that we are talking about. Okay, so the parent function for this, the simplest form of the function, don't forget that, is going to be y is equal to absolute value of x, right? That's going to be the parent function. I'm going to have the chart and I'm going to have the vertex, which is 0 and 0. Substitute something less, something more. The absolute value of -1 is 1 and the absolute value of 1 is 1. And I'm going to graph the parent function. So it's going to be this. Okay. That's going to be my parent function. After that, as you know, I have to go by the order of operation. So the next step is going to be inside the bars. Okay. As I said, the minus is in the formula. Guys, the basic formula for an absolute value function is this. As you see, the minus is in the formula. So if it's plus, it was actually minus that number. So the number is getting subtracted. It is next to x. So what are the changes for? How are the x located? Horizontally. So it's like a horizontal translation. 1 unit to the left. Because the minus is in the formula and I don't see a minus, it was actually x minus -1. So it's like -1 is getting added by everything. Don't forget that, okay? So I'm going to have my x and my y, and I'm going to copy all the y's from the previous chart over here. And I'm going to subtract 1 from all my x's, okay? So it's going to be -1, -1, -2, -1, and 0, okay? So the next step is going to be, don't forget this point. This point is very, very important. Many students make a mistake on this minus and the plus. Sometimes students say, so if it was added, we're going to do the opposite. If it was subtracted, we're going to do the opposite. We're going to add it. Not that it's wrong, but I always recommend my students to learn and not to memorize like rules like this. So the next step by the order of operation is going to be multiplication or division, which is this. Okay. As you see, it's outside the bars, so the changes are for the y, so it's going to be a vertical kind of thing. So it's getting multiplied by 2, so it's going to get stretched. Oh, guys, let's change this to half so that you can see the difference actually. I'm going to change the question into half, because in my previous example, we worked with 2, so we had a stretch. Now I'm going to change it to half. so that we can see a compression. Okay, so all the y's are going to get multiplied by half. So it's like dividing it by 2. So I always use this example. I say, for example, if there is someone and if you divide its height by 2 with the same weight, what's going to happen? That person is going to get compressed. Am I right? So it's like we're vertically having a compression. So a vertical compression by half, and a reflection, because it's also getting multiplied by negative. Reflection over the x-axis, because it's like all the y's are getting multiplied by negative. So if the y's were positive right there, they're all going to be negative right there. So it's like a reflection over the x-axis. So I'm going to have my x copied from my previous chart exactly, and I'm going to multiply all my y's by half. So it's going to be half, 0, and half. Okay, I'm going to, I forgot to graph the green one. Okay, let's go graph the green one first, the previous chart. So it's going to be, the graph was supposed to get shifted 1 unit to the left. Okay, so let's see if it's exactly happening. -1 and 0, -2 and 1. Yes, as you can see, the graph is like being shifted 1 unit to the left very clearly. And now I'm going to go for the blue one. It is supposed to get vertically compressed by half, and it's going to get reflected over the x-axis. Let's see if it's exactly happening. So I have -1 and 0. It's going to be over here. I have -2 and half. So it's going to be over here. This is going to be half. And then I have 0 and half. It's going to be here. Let's plot the points and see exactly what's happening. So as you can see, the graph has been going, actually, it's been reflected over the x-axis and it's been compressed. It's like it has gotten a little bit wider, right? So it's like vertically we have been compressing our graph and we have been shifting it over the x-axis. And the last step, by the order of operation, it is this one. So it's like y is equal to -half x plus 1 minus 1. So it's a vertical translation. So the changes are for the y's because it's outside. So it's going to be vertical and it's going to go 1 unit down. So I'm going to subtract 1 from all my y's, right? From all the y's. So I'm going to copy whatever the x's were from the previous chart and I'm going to subtract 1 from all my y's, okay? So half minus 1, it's going to be half minus 2 over 2, which is -1 over 2. -0 minus 1 is going to be -1, and -1 over 2 again. So it's going to be -1 and -1. It's like this blue one is supposed to get shifted 1 unit down. And then -2 and -1/2. So, oh my God, I made a mistake in the previous part, guys. It was +1/2, but I graphed it on -1/2. Okay. So wait a second, let me fix that. Just the graph, the numbers were all right. Okay, guys, the graph was right. The only part was that I forgot to put the minus over here because you multiply it by negative, okay? So, again, I'm going to go with it. 0 minus 1 is going to be -1. And then -1/2 minus 1 is going to be -3 over 2. And -3 over 2, okay? So it's going to be here. -3 over 2 is like -1/2. So it's going to be here and here. So as you can see, the graph has been shifted 1 unit down and nothing else has happened. Yes. Okay, great. So, yeah, guys, as you can see, it doesn't matter whether you're given a parabola or whether you're given a normal function. The translation and transformation of it is going to be the same thing. There is no difference at all. So, I will also link the previous video in the description box below. Guys, I hope that you have learned the lesson. Don't forget to like, subscribe, and comment. And don't forget to turn on notifications. Also, check out the shorts. They're really funny. Thank you for supporting me. Thank you so much, guys. Love you. Have a great day. Bye.